Thanks for the introduction, Angela. Actually, thank you for inviting me to give this presentation as well. I was asked to do the presentation first before I had an idea on what the topic would be. So I surveyed the, my slides aren't advancing.
The slides aren't.
They're not going forward. Sorry, 1 second, I just couldn't move my slide ahead. Colleen will figure it out. So I was asked to give this presentation and I hadn't had a topic chosen, so I asked around and tried to get a feel for what people would like a topic presented today. So that was the decision for today's topic, which is real world scenarios, and I called it the adventures of an industrial hygienist. I'm going to say industrial hygienist or IH just because it kind of rolls off my tongue a little bit easier, but it's the same as occupational hygienist. So anyone who favors the term occupational hygienist, don't worry, we're all meaning the same thing. I'm just going to say IH because it's easier to say. And so I love what I do, so I was very happy to put this presentation together. I enjoyed it and happy to be here and talk to you about it. What I did was I'm splitting this talk up into 3 parts. The first part is going to be a little bit about my background and some skills that I've identified that I found to be valuable working as an IH, and as well as challenges that I've encountered. The second part of the presentation will have those real world scenarios or situations that I'm going to present, and I'll explain why I chose those ones when I get to them. And then the third part at the very end would be, I'll share some tips that I've learned. Okay, so where I started was originally my interest was in sports and human health. So I went and did a Bachelor of Science degree at University of Waterloo in kinesiology, and the trajectory or the path that I was planning to head towards was sports medicine. Treatment for injured athletes sounded like a lot of fun, but this is where I ended up instead. So I've been an ergonomist and then industrial hygienist, prevention officer, currently the business owner and an IH and an instructor, as Angela mentioned, here at SPPH, as well as for UVic. So these are the industries or companies that I've worked over the past 20-year timeline. It's not everything I've done in the last 20 years, but it was more of a high level, kind of just to give you a feel for it. And if you notice, I've got a little fish icon kind of hovering over the UBC SPPH logo. So that was there to remind me that when I did this program, like 15 years ago or so? I think that sounds about right. About 15 years ago when I did this program, what I really appreciated from it, and didn't maybe at the time that I was in the program, but I do now, is that you learn how to fish. So the expression, give a man a fish, feed him for a day, and teach him how to fish and feed him for a lifetime. Well, that's what was actually happening during the program. It's challenging and it's intense, I recognize that, but if you're gonna be spoon-fed and just given the fish, you won't learn how to fish, and you need to be able to do that in order to transfer over into your future career trajectory. Most of what I'm talking about today comes from just within the last 5 years. So this is with my time consulting with at OEH, and that's goes for the skills, the challenges, and the scenarios as well. So that's where it's all coming from. Here's the first poll question, just to help give me an idea on our audience. Are you a student, a current professional, less than 5 years experience, 5 to 20, or more than 20 years, or other? Well, we got 33, largest group would be 33% student, and then 5 to 20 years is the next largest group. A few in the other, and a few more than 20 years. A few less. Okay, I've got a good feel. Everyone saw those results, right?
That's what it took. Okay.
Go like that?
Yep, you got it. You're on it.
No, I'm not.
good. No, we're not good.
Not good. I just can't move forward.
Interesting. Share results. Share.
There we go. Got it. What do I hit here?
Yep, close that X. There you go. You're ready to go.
All right. Okay. So for skills, observation skills are important. Of course, you're going to be out in workplaces and you need to have your situational awareness and observing for hazards and recognition, right? It's part of what we do to anticipate, recognize. We have risk assessment that comes in with your evaluation process. And something that I've seen quite often is that those risk assessment skills, if they're not strong, people tend to overestimate risk and go on the high side so that they're conservative. Maybe there's nothing wrong with that most of the time, but if it's going to put a heavy burden on the employer, the company, the worker, then you may want to kind of hone in those risk assessment skills. Then there's communication skills, written and verbal, both. Knowing who you're speaking to so that you can speak to them in the right language and the right way of communication. And then written skills comes from the way you write your reports, knowing who's going to read them and writing them well as in email communication. And I have a funny story about radio communication. So we were at a mill and one of our team members was we were given a radio. There was 3 of us from our team at this mill, and we were given radios to communicate with key representatives from different departments so that we could contact the workers that we want to do some air monitoring with or noise monitoring with. And so one of our team members called over the radio, they reached the right department, they spoke to the right person, and then they said, yeah, we want the so-and-so to come put on a dosimeter. And then the other side of the radio just went silent, dead. And I started laughing and our group started laughing and I was like, try again, but say noise monitor. I don't think they know what a dosimeter is, right? So she tried again and she told them, no, we need a noise monitor. We need to give them a noise monitor. And then we got a response. So just remember that, right? Like the language that you're using and the language that other people understand. It's part of communication. But we have technical skills and the instruments. This is a fun part of what we do, or I find it fun, is we have a lot of toys and gadgets to play with. We use different types of gas monitors and we use pumps and calibrators, and we've got all kinds of tools in our kit. And we use these. So there's a little bit of a technical aspect and hands-on aspect to what we're doing, as well, of course, as knowing your math and sciences. Being creative for problem solving and being able to offer solutions. So when you've identified hazards and you want to recommend some controls, so sometimes your recommendations need to be creative, think outside the box. And organization skills is another one. You could go to a site and collect hundreds of samples. You need to know, where did all those samples come from? What were they? When did you take it? Who were you with? All that kind of information. And so managing all of that and being organized in that way is very helpful. Honing in on those organization skills, not even to just mention organizing as in your own time management, organizing your projects, organizing the way you write your reports, right? So being organized is very important, especially if you're busy. I just mentioned that's one of our team members in the photo. We're at a site that obviously sustained a fire and he's doing some air testing there for the contractor who wants to go in and do some restoration work. So these are some daily adventures, I could call them, or they're what we do on an ongoing basis, but it's not everything that we do. But I'm trying to kind of just pick the ones that jumped out at me. Chemical exposure control plans is at the top of the list because we do them quite often. The trigger or the threshold to create an exposure control plan is very low if you have a substance over half of its
and Jeanette.
exposure. If you have a substance that's over half of its exposure limit, you will need an exposure control plan. If it's a designated substance or a product that contains a designated substance, you will trigger the requirement for an exposure control plan. So, silica, wood dust, ammonia, toxic process gases, welding fume, many substances require exposure control plans. So we do that quite often. There's air monitoring, again, just same for the substances that I've mentioned and others. Confined space work, so doing assessments for confined spaces, which I will not talk about today because I know you've had a talk a couple weeks ago on confined spaces. Noise exposure, both measuring noise as well as putting together a hearing conservation program for prevention and to protect hearing loss. You could be writing health and safety programs either at a corporate level, or you could be writing programs for a specific site or a specific job or project. There's regulatory compliance. Either an employer who's being proactive, trying to be compliant and they need your help, or they're being reactive because they've got some sort of compliance enforcement and they're trying to meet the requirement to comply. There's research opportunities. There's instructing, both formal instruction as in, let's say at a university, but also informal instruction. So if you've written a program or an exposure control plan and you now want to train or instruct the workers on how to implement what you've written. And underground tunneling is a unique one. I've probably been in most of the tunnels that have been constructed in the Lower Mainland over the last 15 years. There's a picture of another colleague of ours standing inside of a tunnel. In that photo, I took that picture, and then if you look up from where I'm standing, you'll see the shaft. You'll see looking up out of the shaft, and that's what it looks like. Tunnels are not traditional confined spaces, but they're also not traditional mines, so they're unique. They're a unique workplace. Infection prevention and control is another one. Healthcare, and then we've all got, kind of brought up to speed on this once COVID-19 started. Emergency hazmat response, emergency preparedness, indoor air quality, right? Very common indoor air quality that we get involved with. Hazardous building materials and abatement, things like asbestos or lead usually come to mind, or mold. Fire flood restoration work and support. Contaminants after a fire, how did it affect the building? Where is the soot and flood? Did it cause mold? Kind of investigating that, as well as incidents. And the three that I have highlighted in blue text is just foreshadowing, giving you a hint to some of the scenarios I'm going to talk about. Challenges, definitely there are challenges. First one being industry knowledge. And so I showed you my background a little bit, so you have an idea of where my industry knowledge comes from, but now as a consultant, or if you go into government, you may be working in industries that you've never worked in before, but you have the IH knowledge and you have to apply it to this new industry that you're in, or new to you, this industry. So understanding that industry's processes and operations takes time and takes willingness to learn. So just be patient with that and don't be afraid to ask the stupid questions. There are new substances and hazards coming in all the time that we learn about. There are 120 million different CAS numbers and chemical substances out there. You are not going to know everything about all of them. So that is also a challenge, but as long as you know how to fish, you'll be able to figure it out. Gender could be another problem. So if you are, or a challenge, I would say problem. It could be a challenge if you are, let's say, a female, you go to a male-dominated industry, or vice versa, as well as age. So maybe you're a new graduate and you've learned a lot, you may be relatively young, there may be a little bit of ageism that you could experience as well. And then there's the language and the industry lingo, and that comes part of having industry knowledge. You go to different industries and they use different language. And one word in one industry, the same word in another could have a different meaning. And so this is also a challenge. And you can just smile and nod, but that'll only get you so far. So I got some examples of this language as a challenge here. Next poll question. I've got 3 words: level A, bunker, and drum thief. What industry uses this language? Does anybody know what they mean? So you got 6 different industries to choose from. Level A, bunker, and drum thief. These are new terms to me as well. I learned them just in the last 5 years. Got half the responses in so far. The winner seems to be mining. Any others that want to take a guess? Okay, I find this very interesting in the results. I'm a little bit happy about the results because the lowest one, so 3% for emergency response, is actually the correct answer. So I wasn't alone. I wasn't the only one. So I'll tell you what these are. So now you know. It may be used in mining. Well, I don't know. I don't think the drum thief would. Sorry, Colleen is helping me with the slides after the polls. I kind of get stuck.
Yeah, I don't know what that's about. Here you go.
Okay, so here's level A. Level A is a chemical suit that you wear. It's basically an airtight plastic bubble outfit. It'll protect you from corrosive gases. So that's why they use that in emergency response. The next one is bunker. Bunker gear is also called turnout gear, and it's the typical firefighter outfit that you see firefighters wear because it's got that flame resistant property. And then in drum thief, so if they have a drum that's off gassing or somebody wants, you don't know what's in there, they will take a sample out of the drum by using a drum thief, which is basically a tube that you stick into the drum and then you can collect a sample from it. So there's your drum thief, level A, and bunker. Here's another one. What is a yellow canary? Next poll question. 6 choices. Yeah, all right. Responses are coming in and it's looking good. More than half of you have responded. About the same number as the last poll. Yeah, you can go. So the correct answer is gas monitor, and you guys got this. Good job. We heard yellow canary for the first time, and I wasn't too sure what they were talking about. But I'm going to show a picture of it just for anyone who doesn't know what that was. You can go to the next slide. Yeah, so there's the yellow canary. This is what they were thinking when they said yellow canary to us, as basically, in this case, it was a single sensor for H2S, a gas monitor that they were going to wear, and that was their yellow canary. What I would have called that is an electrochemical sensor, gas monitor, something along those lines. But you know, industries have their thing. So I have another poll question, but we're going to skip it for now, and if there's time, we could come back to it at the end. Here's the first real world scenario. So now the good stuff, right? The reason I chose this one is that a lot of what I'm going to share about this scenario is already publicly available. So the details, I'm free to share them because they're accessible anyway. There's a video here too, so just hopefully this sounds good for you.
Breaks the safety net.
Classes are canceled indefinitely at a Sycamore school because of a strong stink emanating from Parkview Elementary's west wing.
It smelled really gross.
The school district believes the musty odor got worse after a heavy rainstorm, but despite bringing in 2 restoration companies and WorkSafe, it still can't find the cause. That's prompted Interior Health to shutter the school until it knows what's creating the stink and how it can be fixed.
It really makes you wonder kind of what's wrong since they can't figure it out. And, you know, if are we going to be able to open this facility again, or is it going to end up being shut down permanently?
Interior Health doesn't believe there are long-term health effects. It says symptoms such as headaches generally disappear after a person leaves the building.
All right, so what do? Where do you start? You're called now. You get called and you got to figure this out. What is the stink? There are many approaches. There are many ways, you know, to skin a cat, as they say. But what I'm presenting or sharing is just the way that we went. I'm not saying it's the only way you can do it or it was the right way. It's just what happened. So we started off with a typical indoor air quality. This is September of 2019. And you look at the typical indoor air quality parameters: temperature, humidity, carbon dioxide, and carbon monoxide. Not that these would be cause for odor. Actually, they're all odorless. So it's not, but it could be an indicator and it could give you some information about the building. The second thing we looked at were VOCs, so volatile organic compounds, and we followed a US EPA method called TO15 to analyze that. And then we did some fungal or mold sampling from surface and air. So for the indoor air quality parameters, we used a Q-track monitor. You see a photo of it there, what that looks like, and all the readings were normal, right? So let's remember that the building is now shut down and everybody's out, and these readings are normal. Makes sense, no surprise. The VOC readings, we used that canister that you see on the right. It's a big, metal container. It's called a Summa canister. It's under vacuum. It comes from the lab under vacuum, and then you attach a regulator to it, and there are various regulators you could use, 1 hour, 4 hours, 8 hours, and that's the duration it's going to take to fill the canister with the air that in the environment that you put it in. And then our results are in this table, and all of the VOCs that we detected were very, very low concentrations. So these numbers that you see are in parts per billion, extremely low, and nothing shocking, nothing concerning or alarming. But what was really cool about these results, as unexciting as they were, is that they had recently done a roof replacement at the school. And when we asked for the SDSs of the products that they used in the roof replacement, one of the adhesives that they had did contain acetone and toluene in it, and the canister picked that up. So I thought that was fascinating. At a low level, but still it was there, and it collaborated with the SDS. In terms of the fungal samples that we got off of surfaces of anything that we could see, nothing exciting. There wasn't much that we could see, so nothing significant in those results. And then we have the air results. So we use this Anderson end-stage sampling device, which collects, viable living mold spores or fungal spores. And we found that there were, in fact, elevated levels in the crawl space of the school. And we did some statistics to kind of make sure that that difference was significant. And that was with penicillium and cladosporium. So we recommended that, so the crawl space has a dirt floor. We recommended that they could possibly finish the dirt floor or put a barrier. They would need to keep the crawl space dry. So just in high rainfall, which I believe is what happened before this scenario came up, they had some high rainfall. And to keep the crawl space under negative pressure. So if there was any odor or mold spores in the crawl space, to prevent it from coming into the building, you can keep the crawl space under negative pressure so that it doesn't, filtrate to the building. Then we went back October 2019 for further testing. Brought along a few other gas sensors with us. We then looked at some nitrogen oxides and sulfur dioxide. Sulfur dioxide does have an odor. It's an offensive odor, so we thought we would just rule it out. Not that we thought it was contributing to the odor, but we also wanted to rule it out. And the school district was being very diligent, and so they wanted some further VOC testing as well. And we did, again, the fungal or mold samples for surface and air. For the three gases that I mentioned, the readings were normal. We used, or basically non-existent, which would be normal. And we used a multi-ray device, which is like a 5 sensor kind of plug and play. You can swap them out. It's a very handy direct reading instrument that we use often. The fungal air samples, we used the Anderson end stage again, but we also used just your standard biopump and aerosol cassettes as well, which can do both viable and non-viable mold spores. And it supported again that the crawl space does have elevated levels, as well as we did find in the supply closet elevated levels as well. So recommendations were the same. We're still going in this, ending up in the same place, really the crawl space, and then to clean the supply room, because that was really the only difference. So now they reoccupy the building. This is now November of 2019. They've reoccupied the building, and just to be extra certain, extra diligent, the school district wanted to repeat sampling after occupancy and to help, eliminate any complaints or understand what's happening during occupancy. After all, that is when the complaint started. And we did the same, indoor air quality parameters, VOCs again, mold and fungal. And the findings were that the CO2 in the classrooms were elevated. So now we have this occupancy factor played into it. And that we also found elevated fungal or mold samples in the ventilation duct that runs through the crawl space. So recommend from that would be to just increase the ventilation rate for classrooms based on the occupancy load that they have, and clean the HVAC ducts. And of course, the same recommendations before for the crawl space, stay as is, but the odor complaint was no longer there. I think the negative pressure in the crawl space really resolved the issue. Okay. Real world scenario number 2. I chose this scenario. This happened within the last year, so it's recent, but also it was a really good example for me to share on how to fish, right? So it was new. It's not something that you do or see or comment. It doesn't happen every day. And so this is an example of where how to fish really helps out.
After a long night of fighting the fire on board MV Sim Kingston, officials say they have it under control.
The majority of the fire is actually out. We still see it smoldering.
2 ocean cleanup tugs who happened to be docked in Ogden Point were sent to help, spraying water around the area of the fire.
It was really fortunate that they were here and could offer support and are out there offering the support that they can.
Canadian Coast Guard says this kind of fire cannot be directly sprayed with water due to the nature of chemicals on board.
What they were attempting to do is let the fire burn down. In other words, the container consume itself with the fuel while keeping everything else around it cool so that they wouldn't ignite.
The chemical inside, potassium amylxanthate, often used in the mining industry as a mineral processing agent. All vessels and aircraft have been told to stay at least 2 nautical miles away. At this time, however, officials say there is no risk to the public.
Air quality monitoring is setting up on shorelines and on vessels to monitor contaminants and of concern for health of the public and responders. And Island Health is monitoring the situation at this time. And there's no concern of harm to islanders from the fire.
It's not known how many containers were burned in total. As of last night, 10 were on fire. The next stages will be to send hazardous material firefighters on board to see what is still burning. They don't anticipate that happening before tomorrow. Meanwhile, officials are still working to track down the roughly 40 that went overboard on Friday.
All right, that's the second scenario. The thing I liked about this project, what I really enjoyed about it is the team. So it really reminded me of the movie Ocean's 11. I know that's an old movie, but it's a great one if you haven't seen it. George Clooney and Brad Pitt put this team together. They get experts from, I don't know, around the US, I guess. And their goal is to get this $160 million heist out of Vegas casino. And our job was not a $160 million heist, but it's this damaged cargo. So we have this team put together. We have an environmental consultant. You've got the emergency hazmat responder crew, a salvage crew. There's the owners of the vessel. You've got the OEH consultant, which was VOHS. We've got environmental emergency contractor, and they were the Brad Pitt, George Clooney in this story. So they were the ones that were kind of putting the team together. Then we have the port, and then there's regulators. Look how many regulators we have. Transport Canada, Department of Fisheries and Oceans. We've got the Canadian Border Services, Coast Guard, Canadian Coast Guard, Port Authority. There's First Nations, Environment Canada. So when you have this many regulators on one thing, there's going to be delays, just to say. Everybody has to have their requirement fulfilled, and we have to, kind of make sure everybody's got what they need before we proceed. So what we did, and I'm just saying we in terms of the IH consultant or the IH role, was we just assisted with reviewing the cargo manifest. There are thousands of containers on this vessel and on most vessels. So this is not going to be a one-man thing to just go through the cargo manifest. So we supported that. Once you know what's on ship, you can look at the SDSs for the products. And once you look at the SDSs, you can then identify the hazards that you're dealing with. And from there, you can start planning. So put a health and safety plan together for container processing, for the salvage, for disposal. Then you can put a safe work procedure and that plan, choose the right PPE. So what is the salvage crew and the responders, and what are they going to wear when they do this work? What air monitoring are you going to do? And one key with that, again, with different regulators and jurisdictions, is they each had different air monitoring or, exposure limits for substances. So you kind of had to pay attention to that when we were on water or when you're on land, and what air exposure limit are you working with? And then there's radiation monitoring. When everything comes in to Canada that's from overseas, they do radiation screening. And so just to make sure that these goods go through that same process, and also for the crews that are going to be doing this salvage, we can do some radiation monitoring for them. Just to cover our basis. So some of the potential hazards were the fumigants. So not so much a good, you wouldn't call it a good, it's not a cargo, it's not what's cargo, but what they do, how they treat the cargo before it is shipped off, is they fumigate these containers to preserve the cargo and protect it from insects and damage and rotting. Some examples of fumigants that you could find in containers would be methyl bromide, ethylene oxide, hydrogen cyanide, aldehydes, and phosphine. The cargo themselves could be dangerous goods, and so that's another hazard source. And there could be rotting food. So you can imagine these containers were sprayed in the firefighting efforts. It may have gotten wet. Any food in the containers that gets wet, you would expect it to start to rot over, while it's sitting there for weeks. Then there's carbon disulfide. Why carbon disulfide? They mentioned in the news report that there was potassium amylxanthate. And no, I did not know this before doing this project. It's part of the fishing process that you learn. Carbon disulfide will off-gas from the xanthate when it burns. So you have a new hazard created, like one hazard created another, right? So because it burned, we now have carbon disulfide potential from the off-gassing as it burns. And then the radiation, as I mentioned before, could still be a potential hazard. Poll question number 5. The answer to this question is actually on the screen if you know where to look. Carbon disulfide, there's an ammonia pocket guide screenshot there for carbon disulfide. And if you know where to look, you should be able to answer this question. Can a standard photoionization detector, or PID, measure the presence of carbon disulfide? Basically finding out if a PID could be used for detecting any of this off-gassing potential. We almost have a 60-40 split. Yeah, that's it. It's a 60-40 split. The correct answer is true. Yes, you can detect carbon disulfide with a PID. How do you know that? Where do you look? If you see on the screen where I have the shot of the NIOSH pocket guide, there's one on the left there that says IP. I don't know if you could see my cursor, but right here, IP is the ionization potential. It is less than 10.6, which is the standard lamp in a PID. So if your ionization potential is less than 10.6, you can detect it with your monitor. Some lessons learned out of working on this project were what common fumigants were. Before doing this project, I had no idea what fumigants were used in cargo containers. I learned about xanthates. Again, did not know anything about xanthates prior to this. Cargo container design, how they're designed, and there are actually features to the cargo container, which were really interesting to learn about. UN codes that are used to identify dangerous goods. Learn about those, and labels. So you see an example of a label that you would find on a cargo container for fumigation. So if they used a fumigant in the cargo container, you should see a label that looks like this one here. And on that label, they will write down what fumigant was used. So that's handy to know when they applied it and what time they did. Oh, and then there was the network, right? So there was our Oceans 11 team. Our team that we worked with had never worked together before. So seeing this kind of just run through so smoothly was fascinating. It was a great experience. All right, real world scenario number 3. So this is the last one that I have for you. It's hard to put 20 years into a 40-minute presentation, but anyway, so this is scenario number 3. This one's fairly recent, also happened this year. I chose it because the hazardous substance involved is a very common substance. So, and it's also a common hazard. So, there you go.
Good evening. Thanks for joining us. We begin with breaking news. The danger can claim a life in just minutes. And today, a day on the job turned deadly for one man who was killed by an ammonia leak at an ice making company. Angela Jung is following this in the Breaking News Center. Angela, you just spoke to Kamloops fire officials moments ago. What have you learned?
Well, we're learning the people inside at the time were there to do maintenance when the leak happened. And according to WorkSafe BC, ammonia can be so deadly, high concentrations of it can be fatal within just a few breaths. When first responders arrived on scene at Arctic Glacier this morning, they saw a white cloud coming out of the bay doors. That's how they learned they were dealing with a large ammonia leak. People in nearby businesses were forced to evacuate for several hours. The Kamloops Assistant Chief of Operations says 2 of the contractors made it out on their own, and 1 was still inside the building. He later died in hospital.
One of the valves released. When it released, 2 of them made for an exit, and the third one went the wrong direction and got trapped.
The circumstances of this incident are eerily similar to what happened at a Fernie Arena 5 years ago when an ammonia leak killed 3 men doing maintenance in the facility. In this case, firefighters determined a valve opened up, but how that happened is still under investigation. Nijun?
Thank you, Angela.
All right, so ammonia is a common hazard. It's a substance that's common in many facilities. A fatality from ammonia I wouldn't call common. So there were the 3 that happened in 2017 that they mentioned, plus the 4th one that happened this year. So in BC, that's 4 in about 5 years. But ammonia releases happen often. Just you don't always hear about them, and not common that someone would die from it. So with any fatality or workplace fatality, usually the first process and investigation is just to rule out criminal related activity. So the RCMP have jurisdiction over a fatality. Then you also, of course, would have WorkSafe BC who would investigate workplace fatalities. Because this is an ammonia refrigeration system, we also have Technical Safety BC because they are the regulator for the system itself, the refrigeration system. We have Ministry of Environment as well. There was a large cloud released into the environment, so that's an Ministry of Environment issue. And then you have a fire department, we have a hazmat responder, we've got an IH consultant, OEH involved, a refrigeration contractor, so somebody who's specialized in the system involved, and then you would have a medic or a level 3 first aid attendant on the scene. I'm not talking about the investigation, but I can talk about what we did. So we prepared an ammonia ECP, exposure control plan, for the hazmat contractor. We selected the type of devices that were going to be used for air monitoring and assisting with the plan on them entering safely and what PPE are they going to wear. Keeping records of everything that we're doing and documenting that, calibrating the equipment for the monitors that we had selected, and then bump testing it every day that they are being used, identifying hazards, doing the air monitoring, being an ammonia subject matter expert there, and then putting a final report together. So we can talk about ammonia a little bit, but here's poll question number 6. This is the last poll question that I have for you. Can you measure ammonia with a PID? You should know how to find that answer now. An LEL, or what's also called a combustible gas indicator sensor, a flame ionization detector, that's what FID stands for, flame ionization, and electrochemical sensor. So that would be a gas specific for ammonia electrochemical sensor. The NIOSH Pocket Guide screenshot is also there for you to look at. about the same number of people putting in their guesses. Last time we had 60-40, this time we have a 70-30 split. There we go. We'll leave about close to 70-30 split on this one. And the answer is false. It was tricky because it was true for 3 out of those 4 sensors. It is true for the PID. Take a look at that IP number again. You could, the IP number there is less than 10.6. Yes, a PID can detect it. It is flammable, so an LEL or combustible gas indicator will work. And they do make ammonia-specific chemical sensors. However, a flame ionization detector will not pick up on that. And how do you know? Look at the molecular formula here on the NIOSH Pocket Guide. It's got NH3. In order for a flame ionization detector to pick up on it, you want to see a CH in there. CH, carbon-hydrogen bonding. But because we don't see a CH in there, I know, or you would know by looking at this pocket guide, you cannot use a flame ionization detector on this. So here's the pocket guide. I find them very valuable. So once you get comfortable with reading these NIOSH pocket guide information, you can, in less than 20 seconds, you could say 10 to 20 seconds, you'll be able to know, can a PID, FID detect this? Is it flammable? Is it corrosive? Is it heavier or lighter than air? Is it soluble in water? How toxic is it? You can get all of this information in under 20 seconds just by looking here. So this has become my favorite go-to spot. Talking about how to do all of that is not enough time for that in this presentation, but maybe another day, or you can reach out and we can go for coffee. So here are the tips, okay? Tip number 1, we're now in the 3rd part of the presentation. You're not alone, and so because you may encounter some situations you've never been in before, you have each other, you have your classmates that you may have graduated, you've got your worker colleagues, but also don't forget the workers or the employer or anyone who does what they do every day. So just because you may have a master's degree, that doesn't mean you know everything or more or as much as a worker who's been doing their job every day, right? So that's a great opportunity for you to humble yourself when you speak to workers and you want to get information from them, because in that moment, they're teaching you, not the other way around. Tip number 2 is to be resourceful. So I kind of alluded this throughout the presentation, is learning how to fish. Again, you're not going to learn about every single chemical and every single substance in school or in even at work. So you need to learn where to look, who to ask, what to do, who to ask, and so just being resourceful is another tip. Being open to opportunities. So I mentioned before, I started on the sports medicine pathway, but as new opportunities kind of presented themselves, I ended up where I am today, and I couldn't be happier. I love what I do. It's great. I'm very passionate about it. I'll do this on my free time. Yeah, so if anybody wants to ever chat, I'm open to talk about industrial hygiene anytime. Tip number 4 is use technology. I love technology. I use it, I integrate it into everything that we do. I'll just share some of my favorite apps that I use. So the NIOSH Pocket Guide, which you kind of saw how I use that in this presentation. I have the NIOSH Pocket Guide app. Wiser is another app that you use for chemical substances. The NIOSH Sound Level Meter, and the ERG Guide is Emergency Response Guide for chemical substances and what to do in an emergency if something spills. So those would be my top 4. I use other apps as well. And then tip number 5, probably my favorite one, is continuous learning and learning every day. You can learn every day, no matter how long you've been doing this for. I still learn every day, even if it only takes 2 minutes, 30 seconds. You can read, you can learn something from discussion forums, from your local hygiene association, from online webinars, YouTube videos, going out for coffee with somebody who's got a different experience than you. So just learning every day, I can't stress that enough. Or if you're passionate about it, it'll come natural. And the adventure continues. Right now, my current passion is hazmat chemistry, hazardous substances. Kind of wish I was younger so I could do that a little bit more. But I've got my contact information on the screen there, so if anybody wants to ever reach out, say hi, there's my contact info. And I can take questions if there's time.